When the sun dies, it's gonna leave behind something really dense called a white dwarf. Stars with masses that are less than about 8 times the mass of the sun will end their lives by shedding their outer layers in a planetary nebula. Nothing but the hot core of the star is left, and that becomes the white dwarf. Stars die when they can no longer fuse the elements in their core into elements that are more heavy. And for sun-like stars, the heaviest element that they can fuse is oxygen. And when this happens, there are no longer interactions happening in the core that produce the radiation pressure required to counteract the gravitational collapse. So the remnant collapses into the most dense possible object that it can become at its mass, and that's a white dwarf. Since there's no longer radiation pressure going on in this white dwarf, the only thing that sustains it against collapse is electron degeneracy pressure. And this electron degeneracy pressure is due to the Pauli exclusion principle. It states that no two particles with half-integer spins, otherwise known as fermions, can occupy the same state. So the atoms in a white dwarf are truly as dense as you can possibly get at that mass. This stuff is so dense that a single teaspoon of white dwarf matter would weigh as much as an elephant. And when our sun dies, it will leave behind a planetary nebula and a white dwarf like this.